Today, we will be discussing the topic what is sense making and how does it work? First, we will discuss what sense making is. The picture in the upper right corner is the logo for the National Science Teaching Association, NSTA for short. The NSTA defines sense making as actively trying to figure out how the world works or how to design solutions to problems. The picture in the bottom left corner are the four components of sense making: phenomena, student ideas, science ideas, and practices, which we will discuss in further detail in the following slides. All these components allow for students to further discuss their ideas and collaborate. The image that I included in the bottom right corner symbolizes how collaboration can help detangle ideas and make the picture a little bit more clear for yourself and others. First, we will discuss the components of phenomena and science ideas. Phenomena refers to the observation of natural happenings in our world that we can explain and predict using science. Looking at the image in the top left corner, there is a boy observing the grass or plant with a magnifying glass. The picture in the bottom left corner is another example of observing phenomena as the child is actively looking towards the sky, observing the sun or the clouds. Moving our focus to the middle photo, we will now discuss science ideas, aka disciplinary core ideas. Disciplinary core ideas are used to help students understand the underlying scientific concepts related to the phenomena they observed. They act as the big idea. For example, if we were to use the photo of the boy observing the grass, we could then link that to a disciplinary core idea involving life science and zooming in specifically on organisms or ecosystems. This next slide discusses the components of student ideas and practices. Student ideas is the portion of sense making where students discuss the how and the why of the phenomena by collaborating with others around them, as shown in the image in the top right. Students will typically do this by calling on their prior knowledge and experiences and seeing what each individual knows or thinks and what they can put together to form stronger inquiries. When students are calling upon prior knowledge, you may hear things such as, I remember, or this reminds me of, as shown in the activating prior knowledge chart. The last component of sense making is practices. Practices refers to direct involvement of the phenomenon, which is typically a hands on experiment. Completing hands on experiments allows for students to see the behind the scenes moments and really reach for that aha moment. The photo in the top right corner shows two girls completing a hands on experiment. In this case, the students are dissecting an animal. So they are most likely learning about animal anatomy or human anatomy or something of that sort. You can see the expression on their faces insinuating excitement and curiosity. This correlates with the image diagonal from it, showing a kid having that light bulb or aha moment. The purpose of completing hands on practices is to investigate and find out for yourself. To show how all these components of sense making work together, I will now explain how we could use this process in real life. First, starting with the photo in the top right. This image shows a boy watching the rain from the window. This will be our phenomena. Rain is a natural occurrence which is being observed by the boy. To connect this phenomena to science, we will use the science ideas, aka the disciplinary core ideas. Following the arrows to the second image, we will now relate the phenomena to the DCI, Earth Space Science, specifically weather and climate. We will use this DCI to focus as the focus of our lesson or unit topic. This DCI will help us move on to the next step, which is student ideas. As shown in the image again, following the arrows, students will begin collaboration and pulling prior knowledge regarding what they know about rain and the water cycle. Moving on to the last image, students will conduct an experiment. Students will recreate the water cycle in a bag or a bottle, either or works. Students will draw on their object as shown in the image. After drawing is complete, students will place their bag or bottle by the window for a heat source. Throughout the day or days, the cycle will begin and students will first notice evaporation. The heat source will cause the water to evaporate. After water begins to evaporate, the water vapor will begin to collect on the inside of the bag or bottle at the top to show condensation, equivalent to how clouds form and collects rain. The water droplets will eventually get larger and begin to fall back down, equivalent to rain falling, which is precipitation. Lastly, students should see the water collecting again at the bottom of their bag or bottle, just like how bodies of water collect the rain that was once taken from that same body of water or other water sources from the earth. This is the collection stage, the final stage. Students will the drawings Students will have to check in on their project frequently to watch for changes. The drawings on the bottle or bag are there to make the changes clearer and really show them how it works in the outside world. After completing all these steps, students will have a better understanding of why and how it rains, which is the goal. Overall, sense making is used to help students better understand phenomena. When using all four components, students will always be set up for success in the science world. Collaboration and hands on learning can take your students a very long way, especially when pairing that with disciplinary core ideas for the main focus. Finding that aha moment can sometimes be difficult for students. Using the sense making framework will help guide them and prepare them for understanding future phenomena. Thank you.